Welcome to a vertical motion model word problem and a little story about my dog Buttercup. Buttercup was sitting on the grass taking a nap. A flying bird startled her. She jumped right into the air with initial vertical velocity of 14 feet per second. The fact is, Buttercup won't jump. No matter how many birds are flying around her, she won't be startled, she won't jump. She wants to take her nap. But let's make the story happen in a word problem. After how many seconds does Buttercup land on the ground? We're going to use our vertical motion model where h is height in feet. And this height in feet is talking about a projectile, such as when you threw a frisbee, when you threw a ball, when you threw something to someone, or maybe like you read your math book and its animal all of a sudden jump up. All these scenarios, okay? All right, so that's the height. And t, of course, t is time. So this is time. This is also time. What is v? V is initial vertical velocity. That is our v. What is s? S is initial height. Initial height. Keep this in mind. Sometimes the initial height is 0. For example, Buttercup sitting on the ground, that initial height is 0. I squat down on the ground and then I jump up. My initial height is 0. Okay? Now we understand all these parts. I think we can substitute the value we know and solve for what we don't know. All right, let's talk about Buttercup's initial height. S is 0 because she was sitting there. So this is 0. We're looking for the t, so keep the t, don't do anything, and read this part. That's initial vertical velocity. That is our v. That is 14. So we're going to substitute this as 14. Remember, Buttercup gonna come back to the ground. She's gonna land on the ground again, which means finally the height gonna be 0. Okay, all right. Now since this is 0, we don't have to write this blue 0. We can erase this. Now, does this look very familiar? Something you learned from the previous video, your previous lesson. You know how to factor out the greatest common monomial factor, and then you're going to use zero product to solve this equation. Think about 16. 16 is 2 times 8. You might want to say, wait a minute, that's a negative. That's okay. So we're going to say 2 times negative 8. Okay? And think about 14. 14 is 2 times 7. So both of them have 2, but not so fast because t squared is t times t. And here's another t. So both of them can factor out a 2t. 2t. Therefore, we're going to factor out 2t. After factor out 2t, remember that's negative 8, okay? So we have open, close parentheses. We have negative 8t. And let's look at 14t. 14t factor out 2t. 14 divided by 2. We have 7. Don't forget, this equation equals 0, so we will be able to solve it by using our, good, did you say or did you think it's zero product property? I'm gonna write down here. So we have 2t equals 0. t is 0. Remember, we're looking for time. And then we also have a negative 8t plus 7 is 0. We're going to solve for t minus 7 each side, then divided by negative 8, divided by negative 8 each side. I run a space, so I will just go ahead and write down what do we have for t. We have t is 0.875. Remember, that's seconds. Okay? And we're going to take the second one as our solution because it's not possible she jumped into the air, she landed the whole time, only take 0 seconds. It takes 0.875 seconds. Okay, that's how we use the vertical motion model, first concept. And second concept is how to factor out the greatest monomial factor, and then use the third one, zero product property, to solve this beautiful word problem. Happy learning!